What's happening, everyone? So today we're going through your exam questions on two-way tables, frequency trees and Venn diagrams, and this is the first thing that you're going to be doing when we come back into school. Okay, so just to kind of get you aware of the kind of things that you're going to need to be thinking about before we come back in and start doing those kind of assessments each week to go towards GCSE grade. So I've started off this first one for you. So I'm just going to talk you through where each of these things has come from. Remember, the two-way table splits everything up into two categories: the subjects that you're choosing across the top, and then your gender down the side there, and you always put a total at the end. So there were 41 students altogether, so that's where you get the 41 down there from. Okay, 15 of the students chose music. Now that 15 goes there because that is the total for the music. Okay, 30 of the students were girls. Chose to be girls. 30 of the students were girls, so that goes there. Okay, because that's the total number of girls. 8 of the girls chose art, and that is that block there because that's where art and girls intersect, and no boys chose art, so that goes there. Okay, so from there, complete the two-way table. Okay, so pause the video, have a go at completing that, and then when you're ready, come back and we'll go through it together. Okay, so you might do this in a different order, but basically the way that I would look at this is that 8 had nothing, that must be 8 there. 8 girls chose art, no boys chose art, that's 8 people in total, isn't it? 8 at 15 is 23. 41, take away 23 is 18. Just check that on my calculator. Does 8 add 18 add 15 give me 41? 8 add 18 add 15, so that give me 41. Yes, it does. Okay, so I've got 18 there. 18 in total choosing drama. I know that there were equal number of boys and girls choosing drama, so because I'm told that, and only because I'm told that, I can say that's going to be 9 and 9, can't I? This one is going to have to be 11 because 30 add 11 is 41, and then I can figure out what the rest of these are. 0 add 9 add something gets me to 11. What do I add on to 9 to get to 11? It's going to be 2, which means that one must be 13. Okay, and then the final one that you put in, just check the opposite row. So because I used the column to figure out that 13, I'm now going to add this row. 8 add 9 add 13, and if that comes to 30, yes it does, I know I've got it right. Okay, so that's 3 marks, that, dead easy. Right, question 2. Very, very similar, in that this time you're given a two-way table, you have to fill it in again, notice 3 marks again, but then you're being asked to figure out a probability from it. So remember, all that part is that you have to select the correct numbers to go into your fraction for your probability. Okay, so 100 students, each one chose an activity: bowling, kart, or ice skating, and the boys or girls. Complete the two-way table. Okay, so the way that you do that is I'd start with maybe this one and this one. So we do 100 take away 47, that go there. 20 take away 13, it go there, and then you can complete everything else from that. Okay. Now, for this one of the boys is chosen at random. Now, what that means is that when you look at your data, you can only look at the boys row. Okay? One of the boys is chosen at random, which means that our denominator isn't 100 for this fraction. It's going to be 47. Okay? So have a little think about how you can answer that one. And then when you're ready, come back and we'll go through this together. Okay, so what you should have done was 100 take away 47 is 53, 20 take away 13 is 7, and then I'm going to use the calculator for the rest of this. 100 take away 20 take away 26 gives me 54 for this one. 54 take away 34 is going to be 20 in that one. 47 take away 20 take away 13 gives me 14 here. 26 take away 14 is 12, and then I can check 12 add 7 add 34. Does that get me to 53? If it does, yep, I've got it all right, boss. So that's 3 marks for them numbers in there. Right, and then one of the boys is chosen at random. What's the probability that this boy chose carton? So what I want here is just looking at that row, look at the total for that row, that's going to go on the bottom, and the number who have picked karting in that row goes on the top. So that is dead easy. That's just 13 boys who chose karting over 47 boys in total. Okay, and that's it. A really easy 5 marks there, as long as you can kind of remember those basic skills. Right, so well done if you got that one right. Let's have a look at the next page. Right, we're now onto a different type of diagram. It does the same thing. It still sorts it out into boys and girls and whether or not they did homework or didn't do homework. So the maths involved with this is exactly the same as a two-way table. Right? What we have to do is just put the stuff into here and then answer this probability question at the bottom. So 100 students had some homework to do, so there's 100. 42 of these students are boys. So think about where that 42 is going to go. 42 are boys. So there's the boys there, isn't it? So think about where that's going to go. Okay. 8 of the 100 students did not do their homework. Now what that means is that in total, 8 did not do their homework. Now that's a tricky thing to do because remember, that can't just go in there because that's the boys who did the homework. Can't just go in there because that's the girls who did the homework. So these two here must add up to 8. Okay? But it says that 53 of the girls did do their homework. So we're looking at girls who did their homework. It's there, isn't it? Okay? So you can put those into the nodes, into the little ovals in the diagram, and then figure out the rest of it. So for example, if I know how many boys there are, don't I, from there. So if I know how many boys there are, and I know how many people there are in total, I can figure out how many girls there are. And then if I know how many girls there are, and I know how many girls did the homework, I can figure out how many didn't do the homework. So that's the kind of working out that you're doing. It's exactly the same as the two-way table. It's just set out differently. And in this one, again, one of the girls is chosen at random. Okay, so all that means is that you are just looking at the girls' part. Okay, you are not looking at the boys, you are just looking at the girls. Okay, so again, give it a couple of minutes, have a go at that, pause the video, and then when you're ready, start it again, we'll go through it. So 42 of the students are boys, so 42 goes there. If 42 of the students are boys, it means that 58 must be girls, because 58 at 42 is going to give you 100. Okay, 53 of the girls did not do their homework. Sorry, did their homework. So that's 53 in there. So now, if there are 53 who did the homework and there are 58 altogether, it means 5 didn't do their homework. Okay, which means that if 5 girls didn't do their homework, how many boys didn't do their homework? If there were 8 who didn't do their homework altogether, I put them in the wrong place. It should have been there and there, shouldn't it? Okay, so these two must add up to 8. So that must be 3 there. And then if 3 of the boys didn't do their homework and there were 42 boys altogether, that means that 39 of them did. Okay, and the way to check that you've got all these right at the end is to add those 4 up. And does it take you back to the total? So 39, add 3, add 53, add 5, takes you back to 100. So I know I've got all them right. Okay. Now, one of the girls is chosen at random. That means that I am only looking at this part of the diagram there. Okay, and there are 58 girls in total. Work out the probability that this girl did not do her homework. Well, how many of the girls didn't do her homework? 5. So again, really easy, just selecting the correct numbers in the diagram. It's just 5 over 58, so not 53, over 58, and that's it. Okay. So well done again if you got that one right. Let's have a little look at the last couple of questions, both on Venn diagrams. So question 4, the numbers 1, 2, 4, 7, 8, 9, 10, 11, and 12 put into a Venn diagram. The number 3 is in Q, but not in set P, and the number 6 is in set P and set Q. Complete the Venn diagram. Okay, so the number 3 is in set Q, but not in set P. So it's in this circle, but not in this circle, which means that it's not in the intersection, it's just got to be there. Okay, the number 6 is in both set P and set Q, So that will go into there. Okay, so that's just completing the Venn diagram, isn't it? If we just have a little look, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. I think that there should be a 5 on the outside of that as well. Okay, it's a bit weird, that Venn diagram. It doesn't give you too much information, does it? The numbers, what does it put into the Venn diagram? Yeah, I think it should say the numbers 1 to 12 are going to be put in, and we're only missing 5, aren't we? So basically, what you should be spotting there is that P is the 2 times table and Q is the 3 times table. Okay, so that's that done. Student chooses a random number in the completed Venn diagram. Write down the probability that this number is not in set Q. Okay, so how many numbers are in set Q? Well, that one, that one, that one, and that one. How many numbers have you got all together? Count them, and that'll be your answer for that one. Okay, so have a quick go with that and then come back when you're ready. So set Q has 1, 2, 3, 4 things in it. Okay. So how many of these things are not in set Q? So anything outside this oval is not in set Q. So we've got 1, 2, 3, 4, 5, 6, 7, 8 numbers not in set Q. How many numbers in total do we have? We have 12, so that's 8 out of 12. Okay. So well done if you got that one. I'm moving on to question 5. There are 60 students at a college. Excuse me. 20 study both French and Spanish. 13 study French but not Spanish. A total of 43 study Spanish. Complete the Venn diagram. Okay. So remember that 60 will be this number, add this number, add this number, add this number. A total of 20 students study both French and Spanish. 20 study both. Think about where both would go in the diagram. 13 students study French but not Spanish. So 13 will be in the French circle but not in the Spanish circle as well. And a total of 43 students study Spanish. That means that the Spanish oval, the Spanish circle in the Venn diagram has to add up to 43. Okay. And then one of the students at the college is to be selected at random. So we're looking at all the students here, which means that you're using that as your denominator for your fraction. Write down the probability that the student studies neither French nor Spanish. Well, the ones that don't study either will be that one. So it will be that, whatever's there, over 60. Okay, so have a go at that question, and then when you're ready, pause the video, have a go at the question, and when you're ready, we'll go through it. Okay, so 20 students study both French and Spanish. That's going to be in there. So that's 20 in there. Okay. 13 students study French but not Spanish. 13 study French but not Spanish. That's there. A total of 43 students study Spanish. That means the entire circle there adds up to 43. Now that entire circle has 2 numbers missing from it, doesn't it? One of them we already know is 20, so that must be 23. So then to figure out this final one, what we're going to have to do there is do the total, which is 60, take away the numbers that we've got there, minus 13, minus 20, minus 23, which leaves me with 4 left over outside. I don't study either. Right? So when one of the students is selected at random, what's the probability that the student studies neither French nor Spanish? Well, that will be that 4 over the total number of students, which is 60, and that will simplify down to 1 over 15, but that will be fine there. Okay, so you managed to get that right, well done. So can you please take a photo of your work, upload it to Teams as part of the assignment, and that's just done for today. Okay, thanks very much.